Ever wondering why the entire software industry moved from procedural oriented programming languages like C, Pascal, COBOL to object oriented programming like C++, Java, etc.? If you want to know why and how, this video is for you. Hello everyone, my name is Achala Ramakrishna and I welcome all of you for this video in object oriented concepts and foundations. This is one of my favorite video and I'm very good at it, and I hope that I'll do my best. Now, what exactly is the difference between procedural oriented programming and object oriented programming? In procedural oriented programming, the modularity is achieved via functions. So you have functions, right, in the top down fashion, and the data is global. Basically, it is available in structures. But the risks you carry is any of the functions can modify the data. So imagine that you have a balance, and other than withdraw you have other functions, updating the balance. That's a nightmare. There's absolutely no ownership. The change should be done only by one function, and there is a lot of risk because there are several other functions lying. They can get access to that data and update it. In order to solve this particular problem, object oriented concepts got came into picture. Now, instead of modularizing the whole code base, instead of functions, we have objects. Example, in a payroll system, employee is an object, payroll is an object, and database is an object. So the name and salary belong to employee. The calculation of salary is part of the employee class, and it is kind of tightly coupled, so that we basically solve the most important thing. Ownership of data is to the respective entities or the classes. There are no functions hanging on outside. The data and the functions are binded together, and only the class which owns it can call it. So the methods belong to a class and they don't hang in outside. Let us dive in more in terms of what exactly this object oriented concept is. So why do you need object oriented concepts? Now I just wanted to tell you something. I have read this book called Object Oriented Analysis and Design by Sir Grady Booch. This is one of the best books in object orientation. It is little tough book, but I can bet it that if you have lots of patience, you can be one of the best guys in object oriented analysis and design. Now, if you want to build your career as a good designer or a good architect, I think that's where the roots of object orientation lie. Please spend some time and read that book. Now, there are two things. Okay, assume that you are building a very small. Imagine that there is a small town where you have a library where handful of 50 to 100 people come in, do transactions, etc. Now, if you want to build a library management system, you can actually do it in C. The reason, handful of books, handful of users, and handful of transactions. I can actually handle it. But imagine that you are building an air traffic routing system for JFK Airport where every minute you have 100 flights taking off and 50 flights landing. It's going to be nightmare. Even though the code is written in C and the code is like millions of lines of code, you have lots of challenges. One is maintenance of the code. There is absolutely no ownership of the data in terms of which function can modify, which function cannot modify, and not many people have got guts to change those code and all. So I would like to tell you that if your human capacity exceeds to think, exceeds to visualize, then you should embrace object orientation. If you can actually handle it, if you can control it, then you don't need object oriented approach. Procedural oriented approach is good enough. So in one single line, why do you need object orientation is if you are dealing with complexity, if you can't visualize, etc. Now what I wanted to tell you is object orientation is built on these core principles: abstraction, encapsulation, modularity, hierarchy. I'm actually trying to prepare a small note called Basics of Object Orientation. There are two principles are there. You can say the major principles and the minor principles. So abstraction, encapsulation, modularity, and hierarchy. These are all the major principles of object orientation. Whereas typing, concurrency, hierarchy, sorry, persistency, these are all the minor principles of object orientation. So I wanted you guys to understand that if you want to be rock solid in object orientation and you wanted to do good programming in terms of classes and objects, your fundamentals has to be strong in terms of what is abstraction, what is encapsulation, what is modularity, and what is hierarchy. So if you want to understand that, you need to also know what exactly is a class and what exactly is an object. These are very important things. So let's dive in terms of what is abstraction, what is encapsulation, what is modularity, and what is hierarchy. So I kind of love this. So you have a coffee vending machine, right? Basically, what do we think about coffee vending machine is what exactly it do, correct? It can brew, it can dispense. ATM machine, it has a balance. You insert the card and you can withdraw and deposit. When it comes to car, you can fill the fuel and start the car and speed up, accelerate, apply brake, etc. What can you do with the remote? You can change the channel, you can increase the volume level, etc. Washing machine, you can check with the load size and cycle, it can spin and drain. Smartphone, it has a battery level, you can make a call. Nowadays you can watch movies in YouTube, etc. in the phone itself. Each one of it are basically what you can call as objects. Now, what exactly is an object? Before that, you should understand what exactly is a class. Now, in my understanding, if I try to make a small notes in terms of what exactly is a class is basically what you can call as a concept or a specification or a design or a model or a blueprint, whatever you can say. Class doesn't exist. Class is just the thought. And what exactly is an object? Object is the one which provides visibility to the class. Now this is interesting. Object is an instance of a class. Now let us take example and try to understand. Now you have a design of a house. Let's say that you are staying in a villa community. The architect who came up with this villa community has the blueprint of how the villa is going to look like. It's all basically design. And let's say after a couple of years, the construction happens and you have like 400 villas in the villa community, 161, 162, 163. So basically the model of a villa is a class and each villa where it has a specific address is an object. That's what exactly I understand. I have been conducting a lot of corporate training in object oriented technologies like Java, Java full stack, C++, design patterns, etc. And I found something very interesting. Whenever I ask the participants of my class what exactly is a class, I just try to understand, So basically, I actually tell them to make a table like this, correct? And let's say this is a class and this is an object. And I ask them, what exactly, give me an example of class and object. Now, I'll actually share some of the experiences which I have got. So, people say that vehicle is a class and car is an object. People say employee is a class and employee ID, name are all objects. They say furniture is a class, table, chair is an object. They say school as a class, and then they say chair, classroom, students, they're all objects. Now, people, I can actually tell you, have different perceptions about what exactly is a class and an object is. Now, let me discuss about it. Now, let me tell you what exactly I think about what exactly is a class and object is. So, when you talk about class and an object, I can actually tell you is YouTube video is a class, and this particular video which you are watching is an object. Okay. Similarly, you can actually say country is a class and then India is an object. Similarly, USA is an object or Sri Lanka is an object, etc. You can actually say employee is a class and let's say Ram is an object. Student is a class. Hari is an object. College is a class. Let's say Christ College in Bangalore. That particular college which is in towards that Mysore road, that particular college is an object. Similarly, Prime Minister is a class and Mr. Modi is an object. So, cricket player is a class and cricket player is a class. Sachin was an object, now he retired. Virat is an object and Vaibhav is an object. So, bowler is a class, Jasprit Bumrah is an object. World Cup is a class, and the one World Cup which is happening right now, the World Cup football is an object. So World Cup football 2026 happening in the USA, Mexico, etc. Right? That particular thing is an object. Now there is a difference in the way you see about it. If your hundreds of examples are correct, then your concept is correct. Your concept is correct, but your examples are wrong, you're still incorrect. Now vehicle is a class and car is a subclass. So these two things are part of what you can say, they are actually getting into inheritance hierarchy. Okay, they're basically getting into what? Inheritance hierarchy. Okay, now employee is a class, employee ID and employee name are are attributes, they are not classes. Furniture is a class, table is a subclass, they are not objects. School is a class, and you can say, oh, a particular school in your locality where your children are studying is an object. Now, if your concept itself is wrong, if your definition of class and object is wrong, then your design is wrong, your implementation is wrong, what you are going to deliver to your customer is going to be wrong. So you need to be accurate in terms of the concept. Did you like it? I love it. Now this is how you have to see. Okay, if you like it, give some examples in the comment section. What do you think about what exactly is a class and an object is? Now after you understand the concept of what exactly is a class and object is, then you should understand the object oriented concepts. So these are the four basic principles. One is abstraction, the second one is encapsulation, the third one is modularity, the fourth one is hierarchy. Okay, now what exactly is an abstraction? Now let me get into it. Abstraction is the outside view of an entity. What an entity does, not how. We don't care about how, what exactly it is. So that is precisely When I was talking about this coffee vending machine, we just bother about what can we do with the coffee vending machine. So the abstraction of vending machine is the interface of the coffee vending machine, is the services which the coffee vending machine provides. You can select the beverage and it dispenses. That's about it. What is the abstraction of a car? You can fill the fuel, you can start the car, you can stop the car, you can apply brake, you can accelerate. So basically what an entity does is its abstraction. What kind of services which an entity provides is the abstraction of that particular entity. So a class and entity are synonyms, you can actually say that. Okay. Now what exactly is encapsulation? Encapsulation is implementation of abstraction. That means how? Building an entity. Now, if you want to a car to start by just pressing the start button, there's a lot of mechanics involved inside related to engine starting and all. It's pretty complex, and building and doing that kind of implementation is what I can say is encapsulation. Now let me take a simpler example. You talk about coffee vending machine. The moment you select the beverage and you press the start, the internal process which happens, right, where the water gets heated, got it, you get the right components or the ingredients, right, and the mixing happens, etc. Maybe the hot milk gets poured internally, and within just say 5 seconds, when you have the coffee coming out, right, the internal process of how it is implemented is what I can say is encapsulation. So abstraction and encapsulation both complement each other, they really help each other. Okay. Now what exactly is modularity? Modularity is, I can say it is like breaking down of a complex system into what I can say is manageable subsystems. Got it? That means you can't attack a large system in one shot and develop it. You need to decompose or you need to break it out into manageable subsystems. Okay, and then if subsystem itself is complex, again you're going to break it down into manageable subsystems. Finally, each the lowest level of subsystem will have some classes in it, and that's how you build the whole system. In Java, you achieve modularity via packages, right? In C sharp, you achieve via namespaces. Now, hierarchy is all about inheritance. I will get into more details on inheritance as we move on. Okay. Now, what did we understand right now? We discussed about what exactly is a class. Now, tell me what exactly is a class. A class is a concept. A class is a specification. A class is a design. A class is a model. A class is a blueprint. What exactly is an object? Object is the one which provides visibility to that particular class. You know one thing, an object has a state and a behavior, whereas a class has got attributes and operations. We will get into this particular topic. So never mistake saying employee is a class and employee ID and name are object, school is a class and chair and classroom are object. No, that's not possible. So Manmohan Singh, the prime minister, was a class and Manmohan Singh was an object. Now the lifetime of Manmohan Singh as a prime minister is over. Now it is the time of Mr. Narendra Modi, you can actually say. So every object has a lifetime. Every object gets created and every object gets destroyed. Now let me go back to Java and then see how you go about creating the classes. Okay. Now let me create a class. So right click here, new and class. Now let me take for example student is a class. So student has attributes like private int roll number, private string name, and private int grade. Okay. Now basically what happens is in Eclipse is an IDE, right? You can generate getters and setters. I will get into this in detail in my next video. Right now I'm just explaining about how to go about it. Okay. So in Java for a class or in C++ and all, you got constructors also. So you can actually source and constructors and this. Okay. Now the class is done. Now let me add one more thing called as a toString method. What you see is what you learn. So generally what I was telling that today you see, tomorrow you learn, day after tomorrow you apply. So there is nothing wrong about it. So in Java this is how you create a class. Okay. Now class contains student, roll number, name, grade, and right now for now I just have some getters and setters. I will actually tell you how to code in an object oriented way. For that you have to wait for my next video. Now right now what we can actually do is student, let's say student1 is equal to new of student of 1 comma, let's say Rama comma, let's say he's studying in grade 5. Similarly there is a second student and there is a third student. Now you have a student by the name Saket, you have a student by the name Shashank. Let's say Saket is in 7th grade and Shashank is in 9th grade. Now I can actually display each student. There is no point of being good at concept if you can't code it in Java. That's how I say. So basically whenever you use the object name as it is, you know what happens in Java? The toString method gets called. ToString method belongs to object class. Object class is like the mother of all classes. Even though this is just a conceptual session, I'm just coding. I can actually get into the details in my further videos. Now when we run the program, you can see 3 objects getting created. Do you know one thing? Once you design the class, you come up with the model, you define what a class contains, what kind of methods it contains, you can create a millions of objects. Nobody is going to stop you in terms of the number of objects you have to create. You can't create a class for 2 objects, you can't create a class for 5 objects. You just create a class and then you can create as many objects as possible, right? So this is how you design a class. Now there are other details like private, protected, public, etc. These are all known as access specifiers. I'm just think that this is just the trailer of the movie, and in my next video I'll actually get into each and everything, like what is super referring to the parent class, what is this, the one which refers to the current object, right? This is mind boggling. There's a lot to cover as far as Java is concerned, as far as object oriented programming. I just wrote this piece of code for you guys to understand about what exactly is a class and what exactly is an object, correct? So as of now, what are the things we have discussed? What is a, what do you mean by object model? What exactly is a class? What exactly is an object? We also discussed on the basic principles of object orientation, that is abstraction, encapsulation, modularity, hierarchy, etc. Do you know one thing? If you really work on a good project, you will not have 2 to 3 classes. You'll have hundreds of classes. Now, the biggest challenge which we have is how to code which object, whether to use, whether to declare an object as a data member, or you need to pass as a parameter, or you have to define as an inheritance. It's all big confusion, right? I also had it. You know one thing, Java is not my first language. C++ is my first object oriented programming language. So I kind of graduated into Java, and the simplicity of Java really attracted me. So I actually graduated from C++ to Java. Now let me put it across in this way. I, Achala Ramakrishna, who is currently a YouTuber, okay, trying to make some educational videos in object oriented technologies, correct? And I'm ja- I, I'm uploading this particular video in the YouTube, correct? You as a audience are actually, so how do you model visually? How do you come up with design documents, etc.? You need to, you can draw class diagrams, etc. You might have, if you have already working in a software company, then you might have seen the architectural documents, the design documents, etc. You will see a lot of architectural diagrams with class diagrams, etc. Now let me talk about UML. UML stands for Unified Modeling Language. So this is how it is. There were three methodologies. When I say methodologies, object oriented methodologies. One is the Booch methodology, the other one is OMT, and the Jacobson by James Rumbaugh. Okay, so there are three methodologies. One is Booch methodology, one is object modeling technique by James Rumbaugh, the third one is Jacobson methodology. Booch is very good at analysis. Rumba OMT is pretty good at design. Jacobson is pretty good at requirements like use cases and all. So all three methodologies got merged, and the process no became RUP. RUP stands for Rational Unified Process, and the modeling like all the three got modeling languages got merged into UML. So UML stands for Unified Modeling Language. So UML has 5 views and 9 diagrams. So one is the use case view, and then you have the use case diagram. The second one is the logical view, and then you have class diagram and object diagram. The second one is the behavioral view, and then you have the sequence diagram. You have collaboration diagram. You have the state transition diagram, and then the activity diagram. You have the component view, you have the component diagram, and then the deployment view, deployment diagram. So you can actually see that UML has got 5 views and 9 diagrams. I'm going to take you to the class diagram for introduction. See, I just wanted you guys to get the bigger picture about what the whole show is all about. So as I told you, right, today you see, tomorrow you listen, day after tomorrow you learn, then you start applying. There is always a good start, when you go for it actually. Now there are lots of UML design tools are there, like Rational Rose, the oldest one, Together Soft from Borland, and there's a lot of, there's an enterprise architect kind of a UML design tool, and this one I stumbled upon is Visual Paradigm Online. I'm just using the free version of the community edition exactly. Now this is the notation of a class. Now let's say that I say person, and then this is actually what I can call as a, let's say this is a car. Now in UML, person and car, this is a notation of a class. Now it is very difficult to communicate. Now the best way to communicate is to come up with a model. Now, this particular thin arrow is what exactly is known as association. Now, what I am trying to tell you is, in your project, let's say you have hundreds of classes or 200s of classes, how if objects interact. Now, please hear me carefully. Objects interact only when the classes are related to each other. Correct? Let's say you are a person, correct? And in the cinema theater, okay, there is a gentleman who sells tickets. Now, you will go to meet him only when you have to buy the ticket, otherwise, you will never go. So, objects interact only when the classes are related to each other. Now, what exactly the person does? The person drives the car, correct? See, you should enjoy your life. No matter what adversity we are into, we should have fun. Now, you see, person drives a car. Now, what kind of operations you can have? A person can start, a person can stop the car, the person can change the gear in India, obviously. Okay, the person can accelerate, steer, kind of things. So, if you see, no, I say person, I'm not saying car. Now, what is the abstraction of the car? Is you can start the car, you can stop the car, you can change the gear, you can accelerate, you can steer. Okay. What exactly person does? Person basically drives the car. Abstraction is what the car does. How the car does is how the car does is encapsulation, correct? Now I just wanted to tell you, this is something which is very important, very important. See, in my future videos I am definitely going to come into detailing about object oriented analysis and design. I'm going to come up with videos on design patterns and all kind of things. So don't worry, this is just a glimpse of to explain object oriented concepts. I'll actually get into the details. Now we are actually talking about class relationships. Okay, what am I trying to say? Class relationships. Now just wanted to tell you, in analysis, and this is actually called design. What do you do in analysis? You understand the problem. What do you do in design? You understand the solution. Now analysis, you have relationship called association. In design, you have relationships called dependency, aggregation, composition, generalization, realization, etc. Now what am I trying to tell you is, when you are doing analysis, this is a association as a relationship. So in a class diagram, you have different types of relationships are there, like you can actually see association, aggregation, composition, generalization, realization, dependency. Wondering in a Java full stack course why I am explaining all these things is because a Java full stack developer is the closest to become a tech lead. A Java full stack developer is the closest to become an architect or a designer. So if your career progression is towards becoming an architect, then your foundation has to be laid while learning Java, not later on. Okay. Now I wanted to tell you, in your project, if you have like 50 classes, 60 classes, how do you code in an object oriented way? Correct? I'm just giving a glimpse. Now before that, you have to understand that association is a high level relationship, dependency, aggregation, composition, generalization, realization are all lower level relationship. Now let me explain to you what exactly is dependency is. Dependency is a task based relationship. Dependency is a not a lifetime relationship. Let me tell you the sutra. Objects interact when classes are related to each other. If there is no relationship between the classes, objects are not going to interact with each other. Correct? Now, a patient and a lawyer are not going to interact with each other because there is no relationship between the class. A patient and a doctor are going to discuss with each other because there is a relationship between the class. Correct? So, objects interact when the classes are related to each other. No interaction meaning no relationship between the classes. Okay? Now, every relationship is depicted visually in UML. Now, this is the notation. So, actually, see, a person and car are not born at the same time, right? So, the actual relationship is I'm trying to delete this and I'm trying to select this. This particular relationship of dot 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 arrow is there, right? One second, one second. Yeah, yeah. I got lucky. Every tool is different, you have to learn the tool to use it. All the all the viewers, listen to me. If there is a notation like this and the notation is dependency, that is dot 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 arrow, correct? Then it is a dependency relationship. Okay. Now, the next question which comes to my mind is how it is implemented. Let's say that there is a class called person and then there is a class called car. Now, let's have some fun. Imagine you have a start as a method, stop as another method, accelerate as another method, change gear as another method, etc. Okay. Now, you have something like public void drive and you actually pass a particular car as an object. Now, just try to understand if the relationship is dependency between two classes, then it will be passed as a parameter. So, dependency is passed as parameter. Okay. So, here you will say car dot start, car dot change gear, etc. So, what I am trying to tell is if the relationship between two classes is dependency, then in one of the methods the object is passed as a parameter. So, basically when person is equal to new person, you create it and then you say person dot drive of a particular car. Now you have to instantiate car is equal to new car, correct? So, the if you are passing an object as a parameter, then these two are dependent on each other. Are you getting it? This is one of the first relationship between two classes, that is dependency. The next relationship is, sorry, okay, the next relationship is aggregation. Aggregation is one to many has a relationship. What is aggregation? Aggregation is one to many has a relationship. Now let us come here. Now let us design a class called car. Let's say there is a classroom, correct? And let's create another class called chair. Now this relationship is the relationship of aggregation. that is an empty diamond is there. Now classroom contains many chairs, but the cardinality is not fixed. What do you mean by cardinality? The numbers. So technically what do you understand is one classroom can contain many chairs, correct? But it is not fixed. Throughout the life of the classroom there will be chairs. Now imagine in your office or in your college there are plenty of chairs in a classroom, and suddenly there is a big event happening in the cafeteria, and there you need plenty of chairs. What do? They take the chairs into that particular cafeteria and they have it, correct? And once the event is over they bring it back. So it is not sure about, yeah, classroom contains chairs, but I'm not sure about how it is done. Do you know how it is implemented? Let's say there is a class called classroom, and then there is a class called chair. Now in Java, right, you have collection classes, right? So I can actually say array list, chair, and chairs. That's it, is equal to new array list. Now the beauty is you can keep on, you can say classroom is equal to new classroom, and then you can say classroom dot add, and then chair, and then you can say chair 1 or chair 2, you can keep on adding it. So the relationship between classroom and chair is aggregation. It is one to many relationship, but the relationship is not fixed. Now there is, see, in the same lines you have another relationship called composition. What is composition? Composition is is a specialized aggregation, or you can call that as aggregation by value, correct? Cardinality is fixed. Now imagine, now let's see what, how to draw composition. Now in the colleges and in companies, in a classroom, right, let's say there is a projector. Now the relationship is fixed, okay? Mostly it is like one classroom containing one projector, one car containing four wheels, one person having two wheels, correct? One phone having one SIM or two SIM, correct? One smartphone containing one battery. One country has one capital, one country has one prime minister, right? One company has got one CEO. If this is defined, that means the moment you inaugurate a classroom, it has to have a projector in it. Throughout the lifetime of the classroom, it should have the projector. If a classroom doesn't contain projector, it ceases to exist. You can't call that as a classroom. Similarly, if a car contains an engine, imagine you take the engine out, you won't call that as a car. You will call that as a dabba car actually, of no use. Correct? So how is composition implemented, right? Composition is implemented just by creating an instance. So you can actually say projector is equal to new of projector. That means you are creating a, you instantiate a classroom, and the projector object gets created automatically. Both share the lifetime. So what all the things which we learn, if it is not, so this is a dependency relationship, this is aggregation, and this is composition. Now you have one more thing called aggregation, and then you have something like generalization. Generalization is inheritance, or is a kind of relationship. You need to be good beyond language, beyond programming, you need to be good at it. Then you need to know all these things. So let us arrange this little bit. Okay, now yeah, now come up with a class here. We'll call it as a room, and this exactly is the notation for inheritance. So you have another class, and then you can call this as a conference room. You can call as a lab. You can call anything. So you can actually see that lab is a room, conference room is a room, and classroom is exactly the room. So this is how the notation of inheritance comes into picture. Now there is another notation called realization, is when a class implements an interface. I'll talk about it later. Now I can actually say something like that. See, if I want to explain the relationship, I can actually put it like this. Just a second. So we can actually create a class called student, hmm? And we can create another class called called employee, and another class called, let's say, manager. You can say student extends from person, you can say person extends from employee, manager extends from employee. Now here I can actually say something like first name. I can add another thing called last name. Here I can actually add roll number. Here I can say something like employee ID, department, designation, and salary. Let's say here you are talking about number of projects managing, etc. Now the benefit which you have in inheritance is code reusability. Code reusability meaning inheritance is code reusability. Now this current video is for people who are beginner to Java, is also people who have spent 5 to 10 years in Java, because I am trying to explain all the concepts in the nutshell so that you can always visit, come and see it, right. In my future videos I'll get into each and every concept and explain it by coding in detail. So this is exactly what you call as modeling, how you actually visualize. Now you can see first name and last name is part of the person. So student, employee and manager can get benefited out of it. No need to add it. So by implementing inheritance in your project, you organize your code, you modularize your code, etc. Looks like we have discussed the different types of relationship between the classes. Now I actually don't want to show you the slide, I wanted to show you how you code. So you know one thing, let's say you have a Java project, you can do reverse engineering. These UML tools allow you. So once you add your project source directly to the UML design tool, it is going to extract the whole code and give you all the packages, and it can actually give you the classes, relationships, etc. In fact, there are some design tools like Together Control Set, Rational Rows, Enterprise Architect, etc., where you can generate sequence diagrams automatically. Got it? So I think we had a good discussion on object oriented concepts. So let me summarize what we have discussed. We said procedural oriented approach has got its own overheads. Like you say balance. Let's say balance is 1000 rupees. Got it? Now withdraw is not the only function which can change the balance. There can be other functions also which can change the balance. So the ownership of balance is with everybody. That is the biggest problem with procedural oriented approach. Whereas in case of object oriented approach, you're going to create a class called account, balance becomes the attribute, and withdraw becomes the method. Only way to access the balance is create an account object and pass the amount as parameter. You do not have the control of balance at all because balance is inside, balance is encapsulated. That's what actually I can say. What are the benefits of object oriented programming? Sorry, benefits are data production, reusability, modularity, maintainability, polymorphism. I love this concept, and real world mapping. I don't want to talk much about it right now. I will get into it in detail. Modularity is achieved by packages. Got it? Reusability is achieved by inheritance. Data protection is achieved by encapsulation. Maintainability is if a class is well written, it is maintainable, right? Polymorphism is overriding, etc. Now, when do you think object oriented programming scales better than procedural? If if let's say you have multiple developers in your team, oh oops, object orientation handles it. If there is a small variation and keep on changing and changing and changing, object oriented programming works. Correct? If you want to bind data and methods together, object oriented programming works. Correct? If your code base outlives one release, that means code keeps on growing and growing and growing, object orientation actually works. Now let me take the key takeaways of this particular video. We started with what exactly is a class. What is a class? Class is a concept or a specification. And what exactly is an object? Object is the one which really exists. Object is an instance of the class. So if you are drinking coffee, the cup which you are holding, right, is an object. The ring which you have it in your hand is an object. That particular ring which I am talking about. Object orientation is governed by the basic principles. What are they? Abstraction, encapsulation, modularity, and hierarchy. Correct? Yeah. Thank you very much. If you like my videos, please subscribe, please share it to your friends because there is another friend who is preparing for a Java interview and this particular video can help him, get through the first 10 minutes of the interview. I really mean it. If you like my trainings, please uh, please give a comment, and I actually conduct weekend trainings on Spring Boot, React, Kafka, etc. And I do a lot of corporate training for all the big companies. Thank you very much. My WhatsApp number is over here. You can WhatsApp me. Bye bye. Have a good day.